Hi everyone, welcome to geometry class. Today we're going to be in chapter 3, section 6 of our textbook, talking about lines in the coordinate plane. So before we go forward, go ahead and title your notes with this title, chapter 3, section 6, lines in the coordinate plane. We'll be talking specifically about how to write the equation of a line in 3 different forms. Now, this may be a review for some of the forms, but we'll learn about a few new ones today. So the 3 forms we're going to be talking about are the point-slope form, the slope-intercept form, and the standard form of a linear equation. Now each of these have their own uses, and we'll talk about them as we look at their equation for each of the lines. So let's start with the point-slope form. What we're going to be doing is we're going to give a line. We have a line here that passes through point 2, 3, has x-coordinate 2, y-coordinate 3, and another point at 1, 0. And we want to find the equation of this line in the point-slope form. So let's go ahead and write down the point-slope form. It is y minus y1 equals m times x minus x1. And that is inside the parentheses. Now, you might notice that we have m here, and m still stands for slope. The other thing that we need in the point-slope form is just one more point. So let's go ahead and first find our slope. So we'll find our slope using the point-slope form, the slope of a line, which, let's go ahead and label our coordinates first. So we have 0.23 and 0.10, and I have x1 and y1 here, and x2 and y2. So the slope of a line, the equation for that is y2 minus y1 over x2 minus x1. So let's go ahead and plug that in. y2 is 0 minus 3. x2 is 1 minus x1 is 2. So that gives us negative 3 over negative 1, which is a slope of 3. Great, so we have our slope. Now let's look back at the point-slope form. We need y1 and x1, which we actually already have in our first point right here. So let's go ahead and plug that in. Y minus y1 is 3, minus our equals our slope 3, times x minus x1, which is 2. Great. So now we have our point-slope form. This is really useful when all we have is the slope of our line and one point. Okay, let's the point-slope form to turn it into the slope-intercept form. So I'm going to write down the equation we just found. Y minus 3 equals 3, x minus 2. And I want to use this to turn it into an equation in the slope-intercept form. Let's go ahead and write the slope-intercept form down. The slope-intercept form is y equals mx plus b. So I want to get to this equation using what we just found for the point-slope form. So what I'm going to do is I'm going to manipulate this equation to get into this form. And the first thing I want to do is I'm going to go ahead and distribute the 3 to the terms inside the parentheses. And I'll go ahead and expand that right here. So I have y minus 3, the left-hand side stays the same, equals 3x minus 6. Okay, now I'm going to add 3 on both sides to isolate y. So now I have y equals 3x minus 3. Well, and that is in the slope-intercept form. This equation, this form of a linear equation is really useful when I have the slope, and now slope is still 3, but now I also have b, which is our y-intercept. So I know b is negative 3, or the line passes through point 0, negative 3. Okay, at the standard form. Now the standard form is a little bit different. It's going to have a couple of letters that are new to us. I'm going to go ahead and write down the standard form right here. It's capital A, which is the coefficient to x, plus capital B, the coefficient to y, equals c. Now all three, A, B, and C, are all constants in this equation. So I'm going to go ahead and take what we just found in the slope-intercept form, y equals 3x minus 3, and what I want to do is rearrange this to get to the standard form. Okay, you'll notice that I have x and y both on the same side of the equation. So I'm going to go ahead and manipulate the equation that I got in the slope-intercept form to get it into standard form. So let's go ahead and move first this 3, add that to both sides. So now I have y plus 3 equals 3x. Okay, when I want to move the y so that it is on the same side as x, so I have 3 equals 3x minus y. I'm going to go ahead and rewrite that so that it's in this exact form. I'm going to start with 3x minus y equals 3. So that is the standard form of the same exact line that we've been working with in both forms before this. Now the interesting thing about the standard form is that you can actually readily tell the slope, the x-intercept, and the y-intercept all from this one form. Let's look at the slope first, since that's going to be the most important parameter we look at. We want to look at the coefficients a and b to find slope. So slope is going to be the ratio of negative a over b. In our case, a is 3 and b is negative 1. Now we have this negative here too, so the negatives will cancel, so the slope is still 3, which is what we got in the the slope-intercept form and the point-slope form, so that's consistent. Now I also said that you can find the x-intercept, and the x-intercept is going to just be the ratio of c over a. And in this case, that is 3 over 3. So the x-intercept is 1, written as a coordinate, xy coordinate, that's going to be 1, 0. Now the y-intercept is the ratio of c over b. And in our case, that is 3 over negative 1, which is negative 3. Okay, so using the slope, the x-intercept, and the y-intercept, we can go ahead and plot this line. So the x-intercept is 1, 0, so we have our point right here. And the y-intercept is negative 3, or 0, negative 3, which is right here. So indeed, we do have a slope of 3, so let's go ahead and connect these 2 points to make our line. And that is a line that we have been writing the equation of for the last 3 forms. Okay, great. Thing I want to look at before we close up for the day is if I give you a standard form of a linear equation and we need to find the slope. Okay, so to do this we want to isolate y. So let's go ahead and first subtract 3x from both sides of the equation. That's going to be our first step. We have negative 2y left over on the left-hand side equals negative 3x plus 6. And then lastly, let's go ahead and divide by negative 2 on both sides of the equation. So we did isolate y equals, these negatives cancel, so we have 3 over 2 is our slope minus 3. Great, so our slope is 3 over 2. Now this is exactly what we would have found. We know the slope is negative a over b, which is a and b. So that is what we found for our slope. We've looked at the point-slope form, slope-intercept form, and the standard form for the same line. And we've seen how they're all connected to each other and can be manipulated to solve for each of them when we're given one form, or just enough information to find the equation of one line. Great job, guys.